I'm going to talk about the Python-M flag today. I find this flag useful when developing because I can put an if name equals main block at the bottom of a module, and even if it lives in a subdirectory, the imports don't cause problems and I can run that module as main. It's really helpful just to debug stuff and check stuff out on a module level without having to run the whole app. So in the process of learning this M flag, we'll learn a little bit about how the Python import system works, and I think that'll benefit our development, our packaging, and our distribution skills. Let's get into it.
The real clack.
Syspath. Syspath is a list of directories that Python uses to resolve modules when you import them in your Python files. The first element in this list is important. It changes depending on how you invoke your Python program or module. But let's say, so right here we're running app.py as a script. Python app.py. And so what that does, it adds the parent directory to syspath as the first argument. So that parent directory is the first place Python will look after it looks through built-ins and stuff. It'll look at that and then look through the rest of the paths. So that first directory is important. So that's how we resolve modules if we invoke it like Python app.py. Now I'm going to talk about how that syspath changes when we use the -m flag, but first we need to do some module importing in order to properly show that. Let's make a main function that prints hello world, and we can run that. I'm going to comment out the syspath for now, just so we can reduce the noise. Okay. So nothing's getting run because we're not doing anything. We've just made a function. It will get run now because we're running this as a script. We're saying Python app.py, and that means the global attribute name has a value of main. That's the case for anything we invoke directly. We run it directly with Python and then file name. We're going to make like a demo project that does some very simple stuff just to demonstrate the ins and outs of module imports. So I'm going to add a lib file, and it's going to have a function named show, which simply prints a string. So we'll go back to app, and we're going to import show. From lib, import show. I'm going to give this some type annotations. It's going to take a string and return none because it's printing it. From lib, import show. That's what main app.py file says, and we use it in our main. Let's run to make sure it works. Okay, hello world. All right, now let's add another file that lib will pull in called string format. And that has a function called make important. It takes a string and returns a string, and it returns the string but to uppercase. And instead of just printing the string as it is in show, we're going to say make important s. But we've got to import it. So from string format import make important. Let's see if this works. So we're going to run our main again, and it works. Hello world is in caps. So just to reiterate, app pulls in our show function from lib. Lib has a show function, and it uses make important, which it gets from the string format module that sits right next to it. So at this point, we can run every file as a script without any errors. No problems there. What if we want to add a little structure to our app hierarchy? Let's just say we want to make a lib folder and put the the non-app files in there. So we'll put lib and string format in there. So now we have to adjust our imports. Let's see, apps.import lib.lib. And lib needs to import string format. Let's see if this works. Okay, so no module name string format. Let's try that. Lib's not a package. Okay, so let's take a look at the syspath. Syspath shows us packages demo is the first item in the syspath. So it's looking in packages demo to resolve modules. Let's see if that works. And it does. It was just from string format, import, make important. And that's because string format, when we had a flat hierarchy, it was next to lib.py and it was in the root directory. So it was findable. But because it's in lib, which is its own package, and string format is a module in that package, we need to adjust the module path. So we can do that in two ways. We can use the relative import format to refer to the package that lib is a part of, but without explicitly naming it. So the dot really means current package, and then string format means, relative to that, which module. So that's what we have here. We also could do from lib string format, which would refer to the module by its full path. Sorry, I'm running the wrong file. Notice it. So when I run app.py, this works. But when I run lib.py directly, it doesn't work. So the whole point of this video is to show why it doesn't work when we run lib.py. And it doesn't work with the relative or the absolute version. But it does work when we run the main. When you run lib.py directly, it runs it as a script, which means its name is main. And what that does with the syspath is it puts, for the first item in syspath, it puts the parent directory of lib.py. So the parent directory is packages demo/lib. We can verify that if we try to run this right here, lib, right? And so we're inside of lib when we try to resolve this module string format using the relative dot. But inside of lib, we're saying from the current package. Well, it's running as main. There's no package context, right? So the problem is we need to figure out a way for it to see lib as a package and lib.lib as a module in that package. We can do that by running python-m lib.lib. So when we run python-m lib.lib, we are telling Python to load a module that's called lib, that's part of a package named lib, by looking through its syspath. And you notice when we printed out the syspath this time, the syspath here didn't have lib at the end. It has packages demo. So it sees this lib subdirectory as a package, and inside of it, a submodule named lib. So that's why this works. And that's good news, because that means we can do the old app.py standard invocation, right? We can say, like, I'll just do it in the terminal just to make it more clear what I'm doing. Python app.py, it runs the code, no errors. And then we can do python-m lib and then .lib to run the file lib/lib.py. It's hard to think and type. So this gives us flexibility, because the other alternative is to adjust syspath yourself or to just change your imports. And I see people doing that. Eventually, like, you start playing whack-a-mole because you want to run your app, then you want to run your files directly. So this whole thing is to just have a flexible way of running your code. So python app.py, runs the main Python, and then give it the module path, lib python m lib.string format, right? It'll run that too. Let's say we want to run everything as a module. So we're going to adjust our project structure a little bit to account for this. So from packages demo, we're going to type python-m app.app. So that locates the app module within the app package. And it can see that because when you pass the -m flag, it puts your current working directory at the front of syspath. And so from there, it can see a directory named app with a file app.py in it that it can load as a submodule. So we can do that. We can do app.lib.string format, app.lib.lib. So I hope that makes sense. I'll just repeat that when you run python-m and then a module path, it puts the current working directory on the syspath at the front. And if you run Python and then the file name, it puts the parent directory of the file name on the syspath. So that's something to pay attention to if you're trying to debug module imports. Thanks for watching.